Hi everyone. So let's see where we can take this. Let's talk about security. Who has a saying in their company that security is everybody's problem? That normally means it's nobody's problem, right? So that's what I commonly see is like, if you say like something is everybody's problem, it's nobody's real problem. And that probably makes something security like, this is fine. And then you look at common security issues like the OWASP top 10. The most recent list was from 2017. And you see the number one thing they have is injections, which is classical SQL injection, could be NoSQL injection, could be LDAP or some other injection. Basically, you send some user-provided code that is being executed or used in the wrong way in the application. And then you probably say something like, this is fine, and you can see the dogs and the fire kind of changed place already. Where stuff is breaking in a weird way. And then you look at other OWASP top 10 problems that you might run into. For example, insufficient logging and monitoring, where you don't really keep track of what things your attackers are doing. And I think on average, until you detect that somebody has broken into your system, takes 200 days. And if you would monitor properly, maybe you would be able to find that out more quickly. So nothing is fine anymore, and everything is broken and terrible in terms of security. This is what you often have. And this talk is trying to avoid this bottom half where everything is on fire and what the hell is my problem. So we want to avoid these things. So I work for Elastic, the company behind the Elastic or Elk stack. Probably you're using us for logging. And logging is something that you can do here, but it's not the only thing we want to cover in this one. I'm using a Hello World application, so this is a very simple and very bad application. But you will get to do the exploitation, actually. So we will keep it very simple. Everybody can understand what I'm doing wrong. I'm writing terrible code. But for the demo, it will be sufficient for today. So we have a very simple site running, Xera WTF, because WTF is the right domain for any demo. Let's see if something breaks today. And Xera is my Twitter handle and my domain and everything. If you haven't seen it, if you do the rot 13 of my last name, Krenn, you rotate the letters by 13 positions. That is what you get out, Xera. And the nice thing about rot 13 is, if you rotate again, you're back at the original because 26 letters in the alphabet. That's why we get to Xera WTF. So now is your time already where you can grab your phone or laptop, because we will take a look what we have here. So let me open up my browser. So this is what you should get if you go to Xera WTF. So you can see the Elastic employees, and we have Shai, who started Elasticsearch. He's living now in San Francisco. Simon, he's one of the co-founders, based in Berlin, and I'm based in Vienna. So those are the three people we have in our system right now. And now we might want to add more people. Let's say we want to add a new Elastic employee, and obviously you need to log in. And if I try like foobar to log in here, it will tell me, well, this is not the right way to log in. But this code here is the hello world of SQL injections. Let me head over to that one. So the code behind this one here is the classic code that nobody should ever write. Please don't do this. How do we exploit this? What do we do to actually break into the system? Like, you can see I'm just concatenating strings here. For example, name is just passed in as a parameter. What do we add here to actually break through our login? And I'm curious, did anybody already add their own user now? So if you didn't, like something you will probably do is like, we close the string, and then we can just say, or true, and the rest of the string we just comment out. And if you need to keep a password because we have client-side validation to have some password here, but it can be any password. And if you submit this, suddenly you're logged in, and you can just add a new user, foobar from Zagreb, with a very high salary, and foobar as the password. And okay. Somebody has even a higher salary. Okay, so you got the idea of what we're doing here. This is no good. Don't write your code like this. Also, please stick to the code of conduct and don't add stupid stuff here. But your name or anything like that is fine. And then you might say like, okay, let's look at one of the employees. Let's look at our founder, Shai. And you can see here we have Shai, we have his details, and you can see we have here in the URL, we have ID 1. This is the user that we're fetching here. And the next thing we can do then is to look at what is going on here. But before going there, I assume most of you know little Bobby tables. Like, that's how you could name your children to have fun with any system. And that's kind of the thing that we had, or the problem that we have in our example already. So let's see what else is broken or what else we can do in our application. So we have this ID here, 1, and obviously the code is badly written again. But we want to kind of poke it a bit and see what is happening here. So is anybody using SQL map? It's a very nice tool. It's basically trying out random stuff for you to tell you like, hey, there might be a problem with this one here. And basically what you run is you install SQL map, you say, this is the URL we want to test this against, and then I add purge the parameter because I've ran this in the past and it would kind of like keep a past report. So what we do is we run SQL map against this endpoint. It will start testing. Obviously only do that against systems you're allowed to do this, because otherwise you might get into trouble. It already saw that this is probably MySQL, which is correct, so we'll just stick to the MySQL rules. I am okay to run more risky tests, so let's run the more risky tests as well. And this is just running a lot of known attacks against parameters where you could do an injection. You don't need to know or do anything in specific. It will just try out stuff on its own. And at some point, it will return and say like, hey, yes, I think this is vulnerable, or no, this is probably not vulnerable and you don't have any trouble here. I don't want to continue with any other parameters, so we are good here. I'm just interested in the ID parameter. And now it's already telling you like, okay, if you add ID 1 and something equals something, this will bypass it. You could have a timing attack where you could just make the form sleep to figure something out, or you could use a union where you can say like ID equals this here. This one's actually fun if you try this one out in our form. So we add here this ID. And then you can see here we're already doing some injection. And with the nulls in that one, so here you can see null concat something. It already figured out like how many parameters we need to have to insert something. So even if you're not able to break through the login, you will be able to exploit this one. And to keep it very simple, what we can do here is, and you can of course try that out, or this is the underlying code. It's basically the same problem. We have an ID, we trim it, but we don't escape anything, so you can add anything you want in here. And then we just run a multi statement. So you first fetch the ID, but you can run any other statement after that. So what you could do is we could add a semicolon, insert into employees, and then you can add whatever you want and run any random SQL query with that one. If anybody is trying that one out, so this should work as well. So we can just, I'll stick to ID 1. I'll add, no, not this one, but I'll use this one. So I'm adding insert into employee name values bad actor. If I run that, it will show me the ID 1. If I go back at the very end, yeah, very good. This one is the next one. So we can see bad actor is just what I've added. But we also don't escape client side. So somebody already found out that one. If you add script alert something something, it will always pop up with that script alert. So we also don't do the client side escaping of a string. We just interpret everything at code value basically. So I don't have to do this one because luckily you have done that already. So whoever entered oopsie, or whatever else you have, then you have this one here. So all of this is happening, and well, this is good or bad, but probably you want to figure out what people are doing here. So what you generally want to do is you want to see what is happening in our application. And first, some people don't log because they say, well, the attacker could delete some logs. That's probably not what you want to do. Then the next thing that people say, like, I want to log all the things. And the next step after logging all the things basically is you have this log file and you don't find anything either. And that's basically not where we want to end up. So Maybe somebody has heard of the Elk stack, or now we call it the Elastic stack, where we get the data, we store it centrally. Also, if you have lots of systems, it's a bit easier than using tail, SSH and tail to figure out what is going on. So this is what the stack looks like. We just collect the data and we centralize it, and then you can visualize what's going on. And when I have prepared that, like in every good cooking show, I have done all of that. And if you saw the previous example with the code, the SQL query, I was actually logging already. So I have the live stream of whatever is happening on my server here. I can filter down just to my PHP application, so we can do application and luckily it knows everything that we have here. So I've called my application app, which is not very smart, but it works for this example here. And then you can filter down on that one, and you can also turn on live streaming. So this is pretty much like tail F, and whatever you're trying to do, I will see the queries. I can see some people are trying to drop tables. Is this working? Those who try to drop the table, is it working? No, because this is probably breaking the demo. So the user we are using has only select and insert permissions. You cannot delete or drop or anything. I wanted to protect the application a little bit from stuff like that. But yeah, it's very nice that you experiment a bit. So here you can basically see all the things that people try out on my application. You could, for example, say, like here, I'm always adding where this is coming from. So you could, for example, say, I'm only interested in login PHP to only see those. Like you see little dots when something was logged in that file. Like here we have 3, and here we have 56 entries. And you have the highlighting, or you could search for any keyword that you have in here. And whatever you're trying, it will just live stream, and you can basically follow the attacks along, which is nice, but this doesn't solve our problem. So we'll need something else to actually fix this. So we've seen those. This one doesn't work because, well, I saw that one coming. Now we want to protect our application. So there is mod security. Is anybody using mod security already? Not really. Okay, that's good. I can show you something new. So the point of mod security is it's an open source web application firewall. Basically, it's something you put in front of your application, and it will filter out bad requests. So it can look into HTTP and HTTPS requests, and it will filter out certain things that are not supposed to be there. And it has a couple of built-in rules, or you could define your own as well. So there is an open source free rule set that you can use. That's the core rule set, currently in version 3. These are some of the things that it can do. There is also a commercial version that has more features. I'm just using the free stuff because it's more than enough for our use case. And basically what I'm doing is I have my application running on port 443 with Nginx without mod security. That's where we have done all the exploitation against. On port 8080, I have Apache HTTP running with mod security. And if you try to attack or talk to that one, so it's running the same application. You have Xera, WTF, port 8080. If you go to that one, it will serve the same content, but this one now is protected by mod security. So if you try to exploit this one, it will not work anymore. So you can throw all kinds of requests against that, and it will filter it out. So for example, I'm trying out mod security now, and I will run mod security against port 8080. So this is the one that is secured by mod security. It's on the same parameter. It will figure out that it's MySQL at some point. So yes, I want to do more requests like this. And this one here, it says critical. It doesn't appear to be injectable. And it also got an HTTP code back 403. So basically, mod security was filtering out your bad requests and gave you back a 403. So while my code is still totally broken, we put mod security in front of it to filter out the bad stuff. That is especially good if you have an application that you didn't write yourself and you cannot easily patch up to protect that a bit more, or if you have like a legacy application that you don't want to touch right now, to add more protection to that, you can also add mod security in front of it, and it will just try to filter out bad requests that are known bad. So for example, if I have this one here and I run on port 8080, I go back to Shy again to see the record for Shy, and I could add the insert with the bad actor again. Then you would get a forbidden back because, well, mod security figures out this looks like a suspicious request, and it will just block that. Can this go wrong? Yes. Sometimes people have strings that look suspicious, which are okay, but are being blocked. So at first, if you run mod security for the first time, probably just put it into watch mode to make it monitor, and then you log like this might be good or bad, and then you manually look at it and say like, yeah, this is actually a good or a bad request. And only put it into blocking mode once you're sure it's doing the right thing. For example, in San Francisco, there is one big square that's called Union Square. And union is kind of a common term in SQL injections that people try out. And they had, I think at some point they had a bad rule where anything with union in it was automatically blocked. So as soon as you tried to enter the address Union Square into a field, the request would be blocked afterwards. That was fixed in mod security rules, but you need to be careful because sometimes they are a bit overly aggressive and you don't want to have your stuff being blocked there. So this is being fixed now and it knows what is going on. Also, you can look at the Apache logs. We can see here in the last 9 hours, this is when we started running SQL map. You can see we get more rejections now against Apache. We can see which URLs people asked for, what was rejected, and also what mod security was logging here. And we could actually see the rules which have been hitting and everything. One thing that is important is mod security's log format is sometimes a bit painful. You can switch it to JSON, so make it more structured, and then it's much easier to work with. So this will be one of the tricks. If you want to centralize the mod security log, switch it to JSON logging mode, because that will make it much easier to get more value out of that. And you could even add custom rules. So for example, here I'm saying on the form.php, I create my own rule because I have currently a spam problem. So any request that contains pills, insurance, or Rolex should be rejected, because this is a common spam pattern that I've recently seen. And this is how you could just block some bad requests. You don't have to change your application or do anything there. You could just filter it out with the web application firewall. And you could also look into the logs of mod security. So let me remove this one here, and we'll switch over to mod security. If it refreshes, come on, refresh. No, we want to go to mod security. This one here. This looks better. So I can just, you see, these are all the things that mod security is logging here. If you scroll a bit up, you can enlarge this one, and you will see some details. For example, at the very bottom, you will see, for example, this is running on port 8080. You see what the response code was, so this was blocked, and you can then actually see the response body. You can see the user agent, you can see the actual request that was sent, and you can see the rules that matched here. And it is very long and pretty descriptive, but you can see here, this was the regular expression that was matching, that somebody was running a bad SQL statement against my application, and that's why mod security was filtering this one out. So these are just predefined rules that I'm using, and you can look into them and see what is actually being filtered out here. Okay, so that's working, that's nice. Yeah, security is unfortunately a terrible problem. And oftentimes everything is on fire, especially once you turn on mod security, you might see things that you were not aware before, but that happens. So to wrap up, first off, don't write code like me, write better code, and probably use proper libraries. Like for SQL injections, there are a lot of libraries which can make your life a lot easier. So don't rely on handwriting the SQL code for that. Sometimes people ask, like, is anybody using this? Like, is anybody using mod security? And for example, GitLab just added mod security to their deployment less than a month ago. Like, if you run it, it will now run mod security as a web application firewall in front of GitLab, just to be extra sure to filter out bad requests. So they have recently added that. It's getting more and more widespread. If you're asking if anybody is using our stack for logging, yeah, if you're using Slack, for example, security-wise, everything goes into our stack there. So this is like a common combination. So generally, mod security is great, and especially if you combine it with logging to see what's going on, that's a great combination. If you want to try out the code to see like the bad code and how to configure mod security and how to get the logs and everything, this is where you can get the code. Please don't send pull requests to fix the SQL injections, because that's kind of not the point here. But to see the examples and find some bad code, this is what you can get here. So this is the one place where you can get started with that. And with that, I think we have like 3 minutes or so left. If you want to run for lunch, this is your chance now. If you have questions or want to skip the initial queue, just stay here. I also have a bunch of stickers over there. So if you want to get stickers, grab stickers. Also, I normally try to take a picture with you before I finish my talk so I can prove to my colleagues that I've been working. Because they don't know where I am normally. Wave, everybody. Wave, wave, wave. Thank you. So, we have 1 or 2 minutes left. Any questions? Otherwise, if you don't have questions, find me afterwards. I'm happy to answer in private. In general, about our stack, about security, whatever you want. Thanks a lot.
Thank you, Philipp.